Hi, Module 12 is about rational expressions. So what's a rational expression? It is a fraction with one or more variables in the numerator and or the denominator. So examples of what rational expressions are listed right here. They could be really simple, like the first one, or more complex, like the second and third example. So in this particular lesson, we're going to focus on simplifying rational expressions, multiplying them, and dividing them. So let's start with simplifying. So here's number one. I want to simplify 6x squared. There's a missing one there. 6x squared, y to the third over 10, x to the fourth over y. So first thing I want to take care of is simplifying the 6 and the 10. 6 and 10 are divisible by 2. So if you divide them both by 2, you get a 3 here and a 5 in the denominator, which is exactly what you see in the second line. I also need to collapse the variables. I have x squared over x to the fourth that I need to simplify. And so I'm going to use the rule for exponents, which says to subtract. So that's what you see here. I have x to the 2 minus 4. And I need to do the same thing for the y variable. I have y to the third over y. Y means y to the first power, so that's what you see here, y to the 3 minus 1. So in the next line, I did that subtraction of the exponents, which is what you see here. I have 3, x to the negative 2, y to the second, over 5. Okay, so if you recall, we do not want to leave negative exponents in our final answer. The way we correct for that is that we take the reciprocal of the expression with the negative exponent and change the exponent to the positive. So the x to the negative 2 moves down to the denominator along with the 5, and the second power, the negative 2 power, turns to the second power. So 3y squared over 5x squared is your final answer. All right, let's do another one that's also monomial divided by monomial. This is number 2. Again, first, simplify the coefficients. 20 and 5 have a common factor of 5. So divide them both by 5. That gives me 4 and 3 in the denominator, which is what you see here. The a's combine, so you want to do a to the 4 minus 1. And the b's combine, this will be b to the 1 minus 5. When you do the subtraction, you get 4, a to the third, b to the negative 4 over 3. And similar to the last example, we need to correct for this by taking the reciprocal of it. So the b goes to the denominator, and your final answer is 4a cubed over 3b to the fourth power. Okay, let's move on to number 3. Number 3 is not a monomial divided by a monomial. In fact, it's a binomial divided by a binomial. Here, you have to factor before you can cancel anything they have in common. Be very careful not to be tempted to do this. This is incorrect. Just because you see similar things in the numerator and the denominator, in this case, 9, you cannot cancel anything until you have expressions written as a product, meaning expressions being multiplied together. So that's what it means to factor. So x squared minus 9 is the difference of perfect squares. That's x plus 3, x minus 3. And 3x plus 9, they have a GCF of 3, so that's written as 3 times x plus 3. Now that I have factored, I have a product in the numerator and a product in the denominator. Now you can cancel what they have in common. So you're left with x minus 3 over 3, and that is your final answer. Again, be careful not to be tempted to cancel these. You cannot, because in the numerator, it is a difference. So you have x minus 3. If it had been a product, like this, for example, 3 times x over 3, then it would be okay to cancel and then just get a final answer of x. But that is not what we have in here. So you have to leave it as is. Okay, let's move on to another one where you need to factor. I have 2m squared plus 7m plus 3 over m squared plus 4m plus 3. All right, so I'm going to factor the numerator with trial and error. Again, you can use AC method if you prefer. I need a 2m squared in the first position, so I put a 2m and an m. And I need a 3 in the last position, which is what you see here. So either 1 and 3 or 3 and 1 will work. The positioning of the 3 and the 1 is important because remember you need a 7m in the middle. So if you put the 3 here, that'll give you 6, and put the 1 here, that'll give you 1. 6 and 1 gives you 7. Now we factor the denominator, and I get m plus 1 times m plus 3. And then you can cancel your factors, and you get 2m plus 1 over m plus 1. That's your final answer. Now we move on to multiplying. With multiplying, you need to factor as well. It will be a combination of what we did above, as well as some extra work. So in my first example, I have 2x to the 5th over 7y to the 4th times 21y over 8x to the 8th. All right, so 2 goes into 8 4 times. 7 goes into 21 3 times. So you're left with 3/4 as your coefficients. And then I went ahead and combined x to the 5th times y, which is what you see in the second line, and x to the 8th times y to the 4th. All right, so now we're ready to simplify the x's and the y's in this next line. So here, the x's combine as 5, x to the 5 minus 8, and the y's will be 1 minus 4, y to the 1 minus 4. All right, so we do the subtraction in the next line to get this result here, my fourth line down. So I have 3x to the negative 3, y to the negative 3 over 4. But these two both have negative exponents. Both the x and the y go to the denominator, and the exponents change to positive. So we have 3 over 4 x cubed y cubed. And that's it for that problem. All right, so let's move on here to number 2. This is a combination of binomials and monomials. So before I cancel factors, I need to factor this one as a plus 2a minus 2. I went ahead and canceled the 4 and the 12, my coefficients. That's okay. So that's what you see here. So now I'm able to simplify and cancel everything as much as possible. So the a minus 2 cancels with the a minus 2. The x to the 7th in the numerator and the x to the 5th in the denominator, well, that just means that you're going to subtract your exponents. So we get 3x squared times a plus 2. Everything in the denominator canceled, so you only have the expression that you see here in the box. Okay, here's one more. In this example, we have to factor everything. There are no monomials, and so all of these expressions we need to break down as much as possible. Okay, let's start with the trinomial here. This is a perfect square trinomial. So we need a product of 1 and a sum of 2. So the factors that will work are k plus 1 and k plus 1. This is difference of perfect squares. That's k plus 1 times k minus 1. Here we need to factor out the GCF. So I have 6 times k minus 1. And here as well, factor out the GCF. I have 3 times k plus 1. Okay, so now everything is factored. Everything in the numerator and the denominator are just one big product. So now we can cancel. The k plus 1 cancels with the k plus 1. This k plus 1 cancels with this one in the denominator. This k minus 1 will cancel with the k minus 1 in the denominator. So you're just left with 6 over 3, which we know has a value of 2. So all of the variables cancel out here. All right, let's move on to division. Division is almost the same as multiplication except for one additional step. So when you are dividing, and here I have a rational expression with monomials divided by a rational expression with monomials. First step is to change division to multiplication, which is what you see here, and take the reciprocal of the second expression. So the numerator and the denominator flip. So that's your first step. Once you take that step, you are now just multiplying, which is exactly what we did in the previous examples. So now we're looking to cancel what they have in common. So you can see here that the 3 goes into the 15 5 times, and the 4 and 6 have a common factor of 2. Divide that by 2, and so this becomes a 3. So my coefficient becomes 2 times 5, which is here. I forgot to carry that down, so I'm just going to correct it here. So we have 2 times 5, which gives me 10 in my future steps, and my denominator is just 3. Okay, so then I simplify my variables. So notice that here I have an a squared in the numerator, an a squared in the denominator. So basically the a's are gone. There are no more a's in this problem. So I need to deal with the b's. So I have b to the first and b to the fifth in the denominator, so we subtract b to the 1 minus 5. Then I have x's. I have x to the fourth in the numerator and x in the denominator, so you do x to the 4 minus 1. And then I have y's. I have a y in the numerator and a y to the fifth in the denominator, so you combine them by doing y to the 1 minus 5. Again, my denominator is 3. So we subtract. So we get 10, b to the negative 4, x to the third, y to the negative 4. Bring down the negative exponents, they turn to positive. So your final answer is 10, x cubed, 3b to the fourth, y to the fourth. All right, let's go on to number 2 here on the right. So I have 3 x plus 6 over x squared minus 5x plus 6 divided by x squared minus 4 over x minus 3. So step 1 is change division to multiplication, flip the second expression. Okay, but I also did something else. I also rewrote the x squared minus 4 as its factors, x plus 2x minus 2, because it's difference of perfect squares, but now it's in the denominator. And here, factor out a GCF, that's 3. That leaves you with x plus 2. And here you're looking for two numbers that multiply together to give you 6, but when you add them, you get negative 5. So that's x minus 2 and x minus 3. Okay, so now everything is factored. We can cancel what they have in common. The x plus 2 cancels with the x plus 2. The x minus 3 cancels with the x minus 3. So you're left with just 3 over x minus 2, which is the same as x squared minus, didn't write out the whole thing, minus 4x plus 4. So you can leave it either way, either expanded, or you can multiply it out. But it's more typical to leave it like this. It's less work for you too. Okay, so let's move on. Okay, so here we have a combination of a binomial, some monomials, and a trinomial. Step 1, change division to multiplication and take the reciprocal of the second expression. I also went ahead and factored the numerator, which became the denominator. So that's a minus 3, a minus 1. Okay, here I factored out a 4. So that's 4 times a minus 3. And so now I'm ready to cancel anything that's possible. So the a minus 3's cancel. The 6 goes into itself once, goes into 18 3 times. So you're left with 4 times 3, which is 12, which is what you see here. I have an x squared in the numerator and x to the fifth in the denominator, so that becomes x to the 2 minus 5. And you have an a minus 1 in the denominator. So when you subtract the x to the 2 minus 5, that's x to the negative 3. That goes down into the denominator. So your final answer is 12 over x cubed times a minus 1. So that's it for this lesson. Give the homework a try.